Hello guys, my name is Diego Pacheco and this will be another Java video. So today we will be talking about properties. That's the standard way to handle configurations in Java. So today we're gonna focus more towards dynamic properties um, and also in that sense we will be towards dynamic configuration use case, feature flags, feature toggles. So properties are old in Java. They are available since JDK 1. So they are around for a long time. And what I want to show here is basically just the standard SDK in action. There's so many cool things we can do with the standard SDK. There's two libraries that are pretty cool and can help you a lot to enhance your properties capabilities. One being Apache Commons configuration, the second one being Netflix OSS Archaeas, which also uses Apache 1. So talking about Java properties, basically there is two places where you can store these properties. Being the first place, of course, jars when you ship your Java application, or you can store in an external folder. So I found very interesting to store these properties on GitHub. And if you do that, that's gonna give you very interesting GitOps capabilities. Like, first of all, you're going to be able to do time travel because it's going to be version on Git, and easily you can recover old values, right? So that's a very interesting property of versioning configs. That's the first thing. The second thing, if you add these properties on GitHub, is you're going to have something which is PR based. So you're going to be able to do PRs, and you're going to be able to create this property with some sort of a gatekeeping. So you don't allow that properties to change unless someone merge the PR, and that's cool. Also, because it's in GitHub, you can have auditing capabilities. So you can go there and see why change it and can roll back if needed. So you can handle multiple apps and multiple microservices or services in environments like production and lower environments with folders. So you can have something like my microservice, and then you can have folders inside like development, staging, QA, production, or the other way around: development, stage, QA, production, and then inside you have your microservices folder. So it's very easy to organize in a way in a central place to handle all environments, right? So let me show the code because talking is cheap, and we're gonna cover more things in details here. I want to show you some capabilities, and I also want to comment how to avoid some pitfalls that we have when we work with Java properties. So I have a very simple POC here. The first thing I want to show, all right, that although I have JUnity here, this is a test scope. I basically don't have any dependencies, and that's the cool thing about what I'm doing here, just using the standard SDK. Lots of people have like poor understanding about the standard SDK. They often think it's not good enough, it's missing stuff. In parts it's true, but in other sense it's also really cool when you can fix problems using the standard SDK, and you are lean sense of dependencies, you avoid binary coupling, right? So before I show the code, I have some things here, some properties, right? So I mainly have 4 properties here. The first property is a very popular one called log4j, right? So I have a log4j properties here, right, where I have a configuration for a logger. So property files are just key value pairs. They don't have comma, they don't have semicolon at the end, and there's a new line separating one property to another. Another cool thing in properties is if you want to create namespace and hierarchy, you just put a dot, right? So here we have log4j and then root logger, right? So there's 2 levels. And here we have 3 levels, like log4j, appender, and stdout, right? So properties are hierarchical. So that's the standard property. Then I created some custom properties for my app here in src main resources. So the first one, I create this app.properties, and I have this prop called answer 42. This is, although is a cool one, if you get my reference here, this property has a problem, which is I don't have a namespace here. It will be better if it was something like app.answer or app.movies.answer, right? And what I mean by a namespace is like a packaging. So in this way, I avoid conflicts, because now someone can do something like this, all right? And these are different properties. So if you don't have namespaces, you just have like a simple key like here, you can have conflicts pretty easily. So you actually want to avoid names like that, right? So in how you get better and do more with properties is to have this namespace defined, right? And then on that sense, I also created folders, because folders are another form of namespace, and they will be useful when you are loading properties, because if you just load properties by name and you have different jars with the same property, it might be very hard to know where the property came from, right? So of course you can have the same problems with namespaces and folders, but it minimize that risk and minimize that problem. So that's why having like subfolders is a much better structure. So here I created something called config.db, and then I create db properties. So the idea here is to show, oh, let's say I'm using a database settings here, let's say to connect on Redis. Then I have a host, which is going to be a local host, a port, a name of the service, and a version, all right? And I made all this up, right? So I name it as config.db, and then I put like these 4 values here. I also did one for metadata configuration. So I created one called config.metadata.appid. So that's like my unique identifier of my microservice. I create a metadata Java V, which is like the version of Java. And also I created a config metadata owner to see who owns this config, or who owns this library. So in case of maintenance, I know who I can talk with, and it's myself. I can talk to myself. So that are the properties we have, and now I can show you all cool things we can do it and how we can load them dynamically. So I have this main application. As you can see here on my imports, I just have Java Util, Java Net, Java IO. So all standard Java SDK. So here, what I'm doing on the main, I'm showing sort of a different APIs and different things I can do. So first of all, I'm showing how to get a specific property, like I want to get the answer property. And then I have a method for that. Then I have a method that's going to tell me all my sources of property, and I'm going to get a list of strings. Then I'm going to print the source of properties. Then I have one to export properties. And then I'm going to be able to read these properties from system properties. So system properties are sort of a default system level properties in Java. They are not persistent, right? And a property file it is, but you can load from one to another, and I'm going to show how we can do that. And the cool thing, in one line of code, then you can abstract the loading on your infrastructure, and with one line of code you can get access to the property. So I think this is pretty useful. But here I'm accessing the config.db name and config.db host as a system property, and actually these properties are not defined as system properties. They're defined as regular property, but I made them to be system properties, and I did that on the export, and I'm going to show that later on. Here I'm also getting system properties from the config folder and property. And again, these are not system properties, they were exported. And finally, I'm going to show something really cool where you can get remote properties that aren't even on this machine. And we don't need external libraries to do this. We can, again, just use the standard SDK. So it's pretty cool. Okay, so let's take a look on this code. So in order to get a specific property, what you're gonna do is in Java you're gonna have this property object, and I'm calling it props, and then you do a new properties, and then there is this load method, all right? So what I'm gonna do here, I'm gonna get the name of my class, which in this case is main, and I'm gonna do main.class, and I'm gonna do get resource as a string. The reason why I wanna do get resource as a string, because in this way, this is gonna both work in my IDEA, but as I ship this application as a jar, it also gonna work. And then here, I'm asking for a property called app.properties, all right? And that property is this one. It just have the answer there, right? Then once I load the property, a prop is a hash table. So it's like a dictionary, right? So I can do getters and setters based on a key. So I just do get property answer, and then I'm gonna get the value of that. And that's how we get a specific property. Now, let me show how we can figure out all properties we have, and this code can either be running on IDEA or in a jar. But there is a minor change we need to do if depending on of how you're gonna run in this, and I'm gonna show you guys. So here I created a array list, which is a list of string for the result of all sources of properties I have. Then I have this jar file, which is part of Java util jar. And what I'm gonna do, I'm gonna create a file, and I'm gonna do main class resources string. I'm gonna get my main class location, and I'm gonna get the path of that, and then from that path I'm gonna navigate to the upper level, and I want to replace file for slash, right? Because this is a path, and I don't want to the first characters of the path method. Then I want to replace the word classes with nothing. And the reason I'm doing this is because if I'm running on IDEA, this will be running from my classes folder. And then I want to get one layer up. But if I'm running from a jar, I don't need this line. So I added here because if I'm running from a jar, I'm never going to have classes there. So this line will do nothing. But adding here, it may also work with IDEA. Also, because on IDEA, I need to do something else. Because I also going to have the name of my jar. And in IDEA, I'm not going to have the name of jar because I'm not running a jar, I'm running class. So I need to add this so I can look into the jar. So again, if I'm not running IDEA, I can remove all these lines. But I keep it in this way, it works in IDEA and without IDEA. Then I have my jar file. And with that, I can get all the entries inside of the jar. And I'm going to have an enumeration of jar entry. Then I can do this loop of entries has more elements, and I can go through all the entries of the jar. So we are scanning the jar. And then I can get current jar entry, and I can check, okay, does the jar entry end with dot property? If it does, it's a property file. Let me add on my result. Otherwise, I don't care. So I do that. I close the jar. And that's how we pretty much scan all properties in a specific jar or jar of our application, right? Next, I'm going to export the properties, and this is pretty cool. So what I'm doing here, on the previous method, I build a list of strings, but I have all the properties inside of my jar. So I have all my property sources. So from that property sources, I can do a for loop on each property source, and then I create a new property file. I'm doing this code here because when I generate a jar, I'm going to have some metadata from Maven, which I don't care. So in the case I'm dealing with that property file, I want to ignore. If it's not that property file, all right, then I want to load the property. So I want to get main.class.getResources string with the current property that I'm loading. And then for each key value on that property, I want to do this lambda where I am I'm merging these properties with my system properties. And in this case, I don't need to get a specific property because a property only represents one property file. In my case, I have four property files. So I would need to do some sort of locator here to sort of, okay, which property should I use, and then do a getter there. And in this case, because I'm merging all the properties to the system property, I don't need to worry where the property came in from, and I just focus on the key. And that's what we are doing here. And because of this code, that actually all these lines here, they work. And finally, I'm getting a remote property. So this code is also on GitHub, right? So here I have the raw address of this code. If you remember when I showed the log4j properties, it could be any of those, but this one specifically. So what you can do is in Java, you can create this URL, right? You don't need any external framework to do this. And then you create a URL, you have a direct mapping to your properties file. And then what you do is url.openString, and this is gonna give you an input string. And then when you create a property, the load method also receives a header. And this reader could be a file input string reader, could be a input string reader. And that's what we are doing here. We are passing an input string, which is a header, and then we are loading the property. And that's cool because every time this method runs, we're gonna check GitHub and get a remote property. It's very nice, very few lines of code. And this is cool because we can do dynamic properties this way. So either can call this method all the time, and all the time you're gonna check for the latest value of the property on GitHub, or you can have sort of a background thread doing this like every minute or so. Okay, so let me run so you guys can see it works. There you go. So we can see our specific property answer 42. We can see our property sources there, right? And then we can see here our system calls for the system properties. They all work. And also here, we can see my remote property being loaded from GitHub. So these are very powerful APIs. They came from the standard JDK. You can use this to do feature toggles, feature flags, dynamic config. And as you can see, you don't need many lines of code with a very simple class with less than 100 lines. I demonstrated lots of useful techniques you can do in using your SOA services or microservices. So that's it for today. I hope you guys like it. See you next time. Take care. Cheers.